Welcome to part 5, instantiating and running DeathsModel. So here we have our DeathsModel constructor, and we're going to pass it in the data, which is a dictionary of our 4 data frames. I'm going to pass in the last day for training. That's going to be November 5th, the same as with the cases model. We're going to pass in an instance of the cases model that has already executed the run method, and then we're going to pass in the lag and the period. So that instantiates DeathsModel. The run method has to be called to actually execute all of the important code. And you should see that the execution happens immediately because the DeathsModel is much simpler than the cases model. Let's go ahead and see what outcome or output we have here. So first we're going to look at the daily predictions from the US. So these are daily deaths predictions for the first 5 days in the prediction area for the first 10 states. You also have the cumulative, so this will just accumulate these daily predictions for each state, taking off wherever it left off. So just like we did with the cases model, we combined the actual with the prediction. So we have a little bit of, just to show the overlap, so the 3rd through the 5th is the actual data, and then we have the predicted values upcoming over here. So you can see the first 3 rows are for the actual, and the last 3 are the first 3 of the predicted. So we have that, and then here's the same view but for the cumulative. Okay, so that's it for the DeathsModel, and well, there's actually one more method here, the plot prediction. So it's nice to see how we can plot a prediction. So here's one for Texas. This is deaths up to November 5th, and then we have the prediction from November 6th for the next 30 days, and this one did particularly well. So that's the how we can use the DeathsModel class. Now, just a note here, you might be wondering, all right, so we're using a lag of 15, and I sort of pulled that out of the air, but it is based on what is known about the coronavirus. There's typically a 2 to 3 week lag. So what we could have done is automate a process that detected what this lag was for each area. So maybe different areas and different countries have different lags, and we could have certainly done that. And that's certainly something you could do in the future to maybe get a better lag. Now it just becomes a little bit difficult to sort of pick out what that lag is in an automated fashion. So I just decided for now just to use a 15-day lag for all areas. But of course, you'll have some areas that have some sort of different reporting where the lag might be closer to 0, and other areas where it might be longer than 15. So this is certainly something that you can do in the future to improve the model, but 15 should serve as a decent overall indicator or overall lag from cases to deaths.